All right, in this video, we're going to take a look at how to find reference angles. So a reference angle, if you draw an angle in standard position, your terminal side is going to usually end up in one of the four quadrants. And so the reference angle is the measure of the acute angle. Remember, acute means either between 0 and 90 degrees or with radians between 0 and pi over 2 radians. So it's the measure of the acute angle that the terminal side is going to make with the x-axis, either the positive x-axis if it ends up in the first or fourth quadrant, or the negative x-axis if it ends up in the second or third quadrant. So here we have an angle in standard position, and we've opened it up into the second quadrant. And so this terminal side here in red makes an acute angle here with the negative x-axis, and we call that reference angle theta prime. So it's used a lot for finding exact trigonometric values. So for sine, cosine, and tangent, for instance, that are not in the range of 0 to 90 or 0 to pi over 2, we can use reference angles to help find those exact values. It's in the same unit as the given angle, just like coterminal angles. So if you have finding a reference angle in degrees, you want your answer in degrees. If you find a reference angle with radians, you want your answer in radians, just like with coterminal angles. And coterminal angles will have the same reference angles. So you can always use coterminal angles to find a reference angle as well, if that helps you out. So example 5, we're going to find the reference angle for each of the following. We have 150 degrees. So first thing is we can sketch the 150 degrees, and here it is in the second quadrant. And now we want to figure out how many degrees this red terminal side makes with the negative x-axis. So if we went 150, to get to 180, we'd have to go an additional 30 degrees. So 180 minus 150 is 30. And there's our 30 degrees. So our reference angle for 150 degrees is 30 degrees. For part B, finding the reference angle for 225 degrees, we can sketch that in the coordinate plane. And notice this terminal side here makes an acute angle with the negative x-axis. So we need to get back to the 180 degrees. So how many degrees separate 180 from 225? Well, 45 degrees. Take 225 minus 180 in this case. And that's our reference angle for 225 degrees is 45 degrees. All right, part C, we have 300 degrees. So now we're in the fourth quadrant, 300-degree angle. And in this quadrant, we need the quickest way to get back to the x-axis, or the acute angle it's going to make, is this 0 or 360. So it's helpful to use 0 if your terminal side is in the first quadrant, and it's helpful to use the 360-degree coterminal angle if your terminal side here is in the fourth quadrant. So we've gone 300 degrees. We need to figure out how many more degrees we need to rotate to get to 360. So the difference between 360 and 300 is 60 degrees. So that's our reference angle, is 60 degrees. All right, part D, we have 2 pi over 3. Now 2 pi over 3 is between pi over 2 and pi. 2/3 is between 1/2 and 1. You can also, for the radian ones, you can convert to degrees, figure out the answer in degrees, but then you also have to remember to convert back to radians. So be aware that you can do that. Just make sure, again, that you're using the same angle units as what you start with. So 2 pi over 3, and we need to get to pi, so the difference between pi and 2 pi over 3 is pi over 3. So that's our reference angle for 2 pi over 3. If we converted 2 pi over 3 to degrees, 2 pi over 3 to degrees is 120 degrees. The difference between 120 and 180 is 60. So 60 degrees would be the reference angle, and then converting 60 degrees to radians, you get pi over 3. So you can take that option as well. All right, part E, we have 7 pi over 4, so that's going to end up in the fourth quadrant. So we want to get back to 2 pi. And the difference between 2 pi and 7 pi over 4 is pi over 4. If you convert 7 pi over 4 to degrees, it is 315 degrees. So the difference between 360 and 315 degrees is 45 degrees, which in radians, 45 degrees is pi over 4. And that is our reference angle for 7 pi over 4. All right, lastly, part F, we have negative pi over 6. So we remember negative angles rotate to the right or clockwise. Negative pi over 6. If you want to use a coterminal angle, adding 2 pi to negative pi over 6 gives you 11 pi over 6. That may or may not be helpful. I think in this case it's probably not, but the option is there. So negative pi over 6, well, that's the angle. Pi over 6 is the angle that our red terminal side here makes with the x-axis, the positive x-axis. So that is our reference angle is pi over 6. Alternatively, we could have converted negative pi over 6 to negative 30 degrees. So again, this is a 30-degree angle rotated clockwise or to the right. So 30 degrees in radians is pi over 6. So again, you have that option as well. All right, that about does it for this video. Have a great rest of your day.